All right, looking at chapter 7, section 1, A through E, statistics. Okay, we're going to look at some different types of graphs, different ways of showing numbers, statistical items. Our essential question here is, how do you represent data using circle graphs, histograms, and stem and leaf plots? Okay, well, let's take a look at what each of these is. A circle graph, okay, is just that. It's representing information in the form of a circle. A graph in the shape of a circle that shows data as parts of a whole. The percents add up to 100 every time. The data will make up the whole circle. It looks like this right here. Okay, that's a circle graph right there. Okay, how do you go about doing one of those? Well, what you do is this. Okay, you'll be given information. Okay, if it's given in the percent forms, like 30% of the animals in the zoo are zebras, okay, and then 20% are elephants, and so on. Those percents have to all add up to 100%. That means you've got all the animals accounted for in the zoo, okay, for my little example there. That 100% equates to 360 degrees in a circle. When you go all the way around a circle, you've gone 360 degrees, okay? So when you make your circle graph, you have to account for the whole circle, okay, the all 100% of it, okay? To determine what part of the circle will represent each percent, you multiply each percent by 360. So for an example, if they tell you that 35% of the circle what would it represent? What part of the circle? Okay, you take 0.35, that's the 35% in decimal form. You multiply it by the 360, then 126 degrees of that 360 represents the 35%. Okay, remember with a circle now, when we talk about a circle, okay, if you break it up into quarters, each of those quarters, okay, is 40, excuse me, they're 25% of the graph. They make up 90 degrees. Okay, and there's your 360. If you want to take half the circle, okay, that's 50% of the graph. That's also 90 and 90. It's 180 degrees. Okay, you'll see some of that as we go. It's, of course, not crucial, but just to get an understanding of what we're talking about. When we say 35% of the graph, that's a little bit more than a third of the graph, since 33% is a third. So when you do your graph, when you think about that, okay, if I want to just start out here, then I'm going to go about a third of the way. Okay, that's going to be about 35%. Okay, which would be 126 degrees. So if I put this on here, we can see it. If I had a circle here, and I want to go 126 degrees, I would put my point right there, line it up, and I'd go over 126 degrees is right over here. I would draw my line like that, boom. That's about what I got over here. Okay, that's 126 degrees, that's 35%. We'll see some more of that as we go, okay? And then when you get done with everything, it should all add up to 100%, and it should all add up to 360 degrees. What's a histogram? A histogram is just a bar graph, okay? And you've been dealing with bar graphs, I'm not going to make a big thing about that. I'll show you an example of it here in the book. Stem and leaf, okay? If you haven't done a stem and leaf before, this is a stem and leaf, okay? It's a way to show data organized from least to greatest. The least place value forms the leaves, and the next greater place value forms the stem. Stem and leaf, okay? If we're working with numbers in minutes in Mrs. Blackwell's class that each student spends on homework for one night, like one student spent 42 minutes, one did 5 minutes, 75 minutes, and so on. If I wanted to organize this data in a stem and leaf, I would set up like an XY table, stem and leaf. I would put the tens, since the tens place is the biggest place value, the tens place goes here, and then the ones place will go here. So when I get a 0 minutes, that's the smallest. And it might help you to reorganize the data in smallest to largest. Or you can just say, okay, the smallest one is 0. Boom, I got it. 0, 0, 0. Then I've got a 5 minutes, 0, 5, that's 5 minutes. Are there any other single digits? No. So then I go to the tens digit. The tens, I've got a 12. Boom, there's my 12. Then my 20s, there's a 24 and a 23. I'm going to start with the smaller one. 23, I put a 3, there's my 23. 24, 24. And you just keep on going like that. Okay? Now you've got your information arranged from smallest to largest. 0, 5, 12, 13, 14, 30, 30, 39, and so on. Okay? So it's in order and it's kind of organized. You can see that most people spent in the 40s minutes on the homework. Okay? That kind of leads me into the next thing here. Some vocabulary. Okay? When you see the word range, what does range mean? Range means the largest minus the smallest value. If I was taking this data up here, 0 was the smallest and 75 was the biggest. So the range of values here was 75 minus 1. It was 75 minutes. Okay, that was the difference from what the least to the greatest was. The average is the mean. Okay, this one you may have seen before. You want to know the average or the mean? Total them all up, add all the numbers up, and divide by the number of them. Okay. If you want to find the average age of the people in class, you'd add all their ages together and divide by the number of people, and you'd have the age. The median. Okay, you think about the median in a road, it's the middle between the two. Okay, it's that dirt piece in between two lanes of traffic. That's the median, it's in the middle. You want to find the middle number of a set of data, you have to arrange them from smallest to greatest, and then take the one in the middle. Like here, these are smallest to largest. So if I wanted to find the one in the middle, I would start canceling out one end at a time. I'd say, okay, there's my 0, there's a 75, there's my 5, 56, 12, 51, 23, 49, boom. And I'm just working my way down to the middle here. When I get two numbers here, I've got 39 and 42. That's what happens when you get an even number of numbers. Then you can add them up and divide by 2, and you're going to find that 40.5 in this case was the median. Okay. If you had an odd number of numbers, it'll just fall right on one of the numbers and you got it. But if you have an even number of numbers in your data, then it's going to be between the two in the middle. Add them up and divide by 2. It's like finding the average. Okay. And then the mode is what showed up most often. When I looked through here, 30 showed up twice and 45 showed up twice. So I'd have two medians here. I'd have 30 and 45. Those are my medians. They showed up the most. Okay. If everything showed up the same, like we had tens all the way across, then there wouldn't be a mode because they're all the same. Okay. Let's take a look at some examples here. I'm going to use the book for some of this because they do a better picture than what I can draw. Let's say you're looking at, you have to make a circle graph and you get a table of data like this. You're looking at a table shows the endangered species in the U.S. How many mammals are endangered? 68 types. Birds, 77. Reptiles, 14. Amphibians, 11. Okay, so if I had to make a circle graph of this, what I'd have to do is say, okay, that's 68 out of how many? Well, when you add them all up, you get 170. So 68 out of 170 is 40% or 0.40. What percent of the birds are endangered? Well, that's 77 out of the 170, about 45%. What percentage of the reptiles? 14 out of 170. And then the amphibians. And what I've done now is I've got the decimal form of the percents. So then I take each of those decimal forms of the percent to find out what part of the circle, what part of 360 would they take up. I multiply them each by 360. Now, notice these percents will add up to 100 or real close, depending on how you average it or estimated it down, rounded it. And all of these should add up to 360. Again, it could be 1 or 2 off, depending on how you round it. So I start off here with the mammals, are 144%. So if I centered and I put a line down, and then I go around to 144 degrees, boom, there's my mark. It's right there, okay? I make the mark, I draw a line and say, that's my mammals. And I'd start there and say, okay, I found that 6%, that's the amphibians. Okay, and I'm just working my way around here. It was 22 degrees, so there's my 0 line. I go over to 22 degrees, boom, I put a mark, draw the line, boom, there it is. And I'd keep working myself around, okay? I'm doing this kind of quick right now. We're going to take some time with this in class to show you that. And you should also be able to notice by looking at this that the biggest portion um, of endangered species is the birds, which was the most here. Okay, so the most here should have the biggest piece of the pie. Okay. Histogram. You've seen plenty of histograms here. Bar graphs, anything like this. Okay, here's 2 examples here. You're used to those. Okay, if you get a set of data and you got to find out, how many were between 81 and 110, we'll just count out how many and then just boom, you go up that high. Okay, I'm pretty sure you've seen this stuff. Again, we're going to take time in class to do those. Okay, and I showed you a stem and leaf. We'll take time in class to take a look at each of those, not just how to make them, but to be able to interpret the data. Because graphs are huge these days. You see graphs everywhere to show information. It's easy to show a picture of a graph to get an understanding of what it is. And graphing calculators, as you get older and you move up in math and whatnot, you'll see that there's a big use for them because we interpret so much stuff into graphs. You get an Algebra 1, you do a ton of graphing, and Algebra 2. Okay? All right, hopefully that's been helpful. We'll take class time in here to get on that.